All right, okay, let's try this again. Class?
Yes.
All right, thank you. You guys are like energetic. It makes me excited to do this. All right, so what page are we on?
41.
41, thank you. So 41, so trees.
Yeah.
So trees is,
Provides oxygen.
yeah, okay. But what we're talking about is like graphing trees. So it's actually,
Oh.
it's a,
Well, that's not fun.
yes it is. Okay, so let's say for instance, there is a single route that Tony's gonna take and he's gonna go, hey, I need to go from here to my dealer. Okay, but you're gonna give directions and what we're gonna do is there only is one specific way that you can go.
All right, pass it the directions, man.
Okay, and that's what we're gonna end up finding. We're gonna find the best route. Trees. A tree is a graph that's connected and has no circuits. Now, do you guys recall what a circuit is?
Yes.
What's a circuit?
A complete loop.
A loop, right? A loop. So it just goes back and around, right? So a tree, hey. I know that's not a phone in your hand, right?
No,
Oh, hell no, right? No. Okay. Okay. Good. All right, so a circuit can be inside of the whole thing. So any part of it that's going to go back around. If it could make a loop, then any part of it would be a circuit inside there.
Which means it's not a tree.
Yep, so it would not be a tree. There is one and only one path joining any two vertices. Only one path. I can only go one way to go from Tony's house to his dealer's. Okay? There's only one way.
Straight down the street.
Okay, yes. Okay.
Would
So
you be making a loop back to your place, though?
no. Because yeah, you don't want to do that because his FBI that's following him, you want to make sure you go somewhere else so you're not you're not bringing him back to your house. Okay. So and then every edge is a bridge. So we're referring to each one of the sticks that connect each of these vertices as an edge, and they're going to be bridges. A tree with n number of vertices has n minus 1 edges. That's important. Okay? That's important. That's going to tell us how many bridges we are going to use to be able to connect all these places. Alrighty. Which of the following graphs are a tree? So, look at A.
Thanks.
Is A tree? Say no.
No.
No! Are they connected?
No.
They're not all connected. So we have that one way out there. Okay, this one right here. This one over here. So it's like, hey, if it's not connected, then Tony can't get to his dealer over here.
For real, man.
I know, he's got to have a route to go from there to his dealer.
He needs his meth.
So this one is not connected.
Is that your driving test this week? Really?
Is this one going to be a tree?
Yes.
Yes, it is. Guess what? We can go from Tony all the way over to the dealer, but there's only one route that he could take. Only one specific route. There we go. Only one route. This one over here, C. So
Not
this
a
one,
tree.
No.
Because it
Why?
has a circuit.
very good. It has a circuit.
How do you
So-
spell circuit?
Good. I don't know.
Cricket.
I don't know. Yeah, I can never get that one right.
C-I-R-C-U-I-T.
I believe it's on the previous page.
Probably.
Yeah, probably, right? It's in the definition of circuit.
Okay.
All right, so this one is no. So this one is not a tree because it has a circuit there.
That's easy.
¿Está muy fácil?
See?
Sí. Muy.
Well, now this part gets
Now it's even easier. Okay, spanning trees subgraph. Now we're going to take a graph, which this is the original graph over here on the left. Subgraph is a set of vertices and edges chosen from among the original graph. The original here.
Okay.
Okay? So I only could use the original edges, and now I'm going to make it into a tree by taking away some of the ones that I'm going to use. I don't have to use all the edges. I don't want to use all the edges. So what I'm looking at here is, if you look at this first one, there's There is no circuit, is there? No, there's no circuit. So that one's good. Now, there's also going to be the n minus 1 thing. There is 1, 2, 3, 4, 5, 6, 7. So n equals 7. So how many bridges?
6.
6 bridges. So there's going to be 6 bridges. Let's see. So by doing it correctly, let me see. 1, 2, 3, 4, 5, 6. 6 bridges. They're all connected. So now I can go right here. So I got Tony over here. He's going to Jishan's house. And then he's going to end up over here at the dealer's house. Because Jishan has the money.
So
And Tony's got the car.
what about the parts in between?
Doesn't matter. There's only one route that he could take. So there's only one. So no matter what, the only route is Tony starts here.
Oh.
He has to go to Jishan's house.
Because it's on the way.
Yeah, it's on the way, but guess what? He has to go there anyway. There's only one route to go from A to D.
So as long as it's not a circuit.
It's not a circuit. Because if it were to go, that would be a circuit, and that would be wrong. Okay?
Wrong.
Wrong.
Jeez.
There you go. All right, this next one over here. If you notice, 1, 2, 3, 4, 5, 6. Is there any circuits there?
No.
Nope, no circuits. But there's only one route now. Okay, there's only one route. So now this time we have Tony. He's going to go this way here, and when he ends up at F, he could either go to his dealer or he can go to Jishan's. One or the other.
Scoopy just trying to go to the dealer.
But you can't go back.
The dealer.
Jason, did you agree to this?
Bro, I would literally be waiting at the F already.
He literally be locked in.
All right. So, does this make sense? Is it
Yeah.
basic? Seriously? Yes.
Yes.
Okay. All right.
It's simple. It's a simple concept. It's just a hard concept to grasp.
Okay. Now let's look at this. Let's count how many vertices I have. 1, 2, Okay, there's 8.
That is really good.
Oh yeah, I really wasn't gonna go all the way to 8. Okay. So there is 8, right? So in this case, I would say n equals 8. Come on. So that means how many bridges am I gonna have?
7.
Very good, 7 bridges. So now I'm going to connect all these, but I only could use 7 of them. And I cannot make any new roads. Write that down. I cannot make any new bridges. If there is not a line already there, I cannot put one there. Does that make sense?
Yes.
Good. So, 7. So let's see. I'm going to go through and I'm going to start connecting them. All right, that's going to be 1, 2. Got to make sure I don't have any circuits. 3, 4. Okay, and let's 5, 6, and 7. So now I put in 7 bridges. I did not use all the edges here, right? I didn't use all the edges, but what I did here in red is there any circuits? No, no circuits. No circuits, but right here I was able to show everything I have. Does that make sense?
Yes.
So this one is a tree. And there's more than one possible way of doing it. There's a whole bunch of different possibilities. And if you did something differently, it's still correct. You just have to make sure there's no circuits and everything is going to be connected. So again, so if we're starting at Tony's house, there's only one specific way that he can go down to his dealer. Right? Only one way that he can go to his dealer. He leave Tony's house, bam, 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 bam. There we go. He has to go that way. Yes? Does that make sense? Okay. All right, good. Now, minimum spanning trees. Minimum means the smallest number. I want the smallest number. Yes? Yeah, go ahead. Mouse right there. Minimum, the smallest number. Spanning tree for a weighted graph is a spanning tree with the smallest possible weight. From the spanning tree below, we see that this one, C, has a smaller weight than B, but is the minimum spanning tree, or we should continue to find other possibilities. Okay, trees that may have total weight less than 107. All right, let's look. So looking here, this is the original. That's all of them with weights on there. That's all of them with the weights. And if I'm looking right here, when I did B, I came up with 119. So I went all these, so I add these together, bam, bam. This one over here, I had 35, 17, but instead of going down here, I did 12, 15, 8, and then down to 20. So this one came with the smaller number of 107. So we're always going to be looking for the smallest number here. That's what minimum means. Right? Hopefully? Good? Hopefully not too boring. All right, couscous algorithm. Okay, there's a whole bunch of words here, and you'll probably fall asleep by the time I'm in. All right, here we go. Use couscous. Cusco? Yeah, Cusco's algorithm. That's what it is.
Crustable?
Huh?
Crustables?
Cusco. 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 I don't know. I don't know. Some guy that has his new groove or something. All right. So, using Cusco's algorithm, we complete minimizing a spanning tree in a series of steps. So, what we're going to try and do is we're going to connect all these using Cusco's algorithm. Okay? And I'm going to show you step by step because I'm pretty sure you would fall asleep if you tried reading all those steps. So, this is what you're going to do. Start with the smallest number. Find the smallest number. 242?
Yeah.
Good. Draw that one. So that's one that I'm going to use. Next one. What's the next smallest number? 245?
245.
Okay.
D to D.
There we go. So I'm using that one.
249.
249 is the next one?
A to D.
Okay. 249. There we go. All right. And keep moving on up.
251.
Now, which 251? Am I going to use AB?
No.
Why no AB?
Because we already, it'll make a circuit.
Very good, everyone. It will make a circuit. So I'm going to use this one here. So if it didn't make a circuit, I would try and use the 251 over here also, if it didn't make a circuit.
253.
Okay, so after that, 253.
And then that's everything.
And all of them connected. And the last one I have to connect, 259. So let's see, how many did I have? 1, 2, 3, 4, 5, 6, 7. So if n equals 7, that means I should have 6 bridges.
Wait, where's the 7? It's 6. Oh.
1, 2, 3, 4, 5, 6, 7.
Oh.
Did you count D?
Yeah, I was just counting bridges, no.
Oh, okay, no. I'm counting the vertices so you could actually see it, n equals 7. So it gives me 6 bridges. So do I have 6 bridges? 1, 2, 3, 4, 5, 6. 6 bridges. So I know I did it correctly. So they all connected, there is no circuits, and so that one should end up becoming my smallest. So what's going to be the weight? That's the one I'm looking for now. So please add those together.
245.
All right, and it should come out to be
But for your background, $14.98.
Even you.
is that pretty good?
Yeah.
You guys agree, or anyone questions so far?
Questioning his sanity.
Yeah, we all do. I did that myself this morning.
Your sanity?
Yeah.
You don't know what your sanity is. Oh my god, you're insane in the membrane.
All right, and guess what? That's it. Make sure you guys all like, share, and subscribe. Hit that notification button and use promo code EARLYBIRD. Get 10% off the merch store.